Hello, everyone. Welcome to the session Designing for High Performance in Power BI. My name is Siva Harinath. I'm a principal group manager in terms of supporting websites, community training in the digital transformation platform group. Along with me, I have Phil Seamark. Phil, if you can introduce yourself, that'll be great.
Yep. Hello, my name is Phil Seamark. I work on the Power BI Customer Advisory team, which is a team that quite specifically spends a lot of time with very large enterprise customers, helping them iron out interesting challenges and helping them get the best out of Power BI.
Yeah, thank you, Phil. So today, we want to go through in terms of the list of things which we are going to talk about today. So today's agenda, so we'll cover in terms of key things with respect to performance. How does performance affect your dashboards and reports and the data refreshes? Identify the common areas in terms of choices people make and like what you should be making. And what are the common mistakes we have seen from experience in terms of when I was architecting solutions for customers and then Phil and the entire customer advisory team. So these are all the learnings. And we also will recommend how to mitigate these issues so that you can proactively solve these problems rather than these problems becoming later at a later point in time. Okay. And finally, we will also be able to share a set of tools that will help you to in terms of investigate the end-to-end system behavior, as well as a framework for you to make sure that you are architecting your solution with performance in mind. Okay. So what this session is not about, we are not going to be covering high scale architectures in terms of, especially if you're familiar with analysis services and replica and scale out and synchronization, we're not covering that. And we, in most of the cases, we'll go through some of the things in terms of key points. We'll not be able to cover every single thing, but we will give the most important tips. And there's not enough time to go through each and every DAX optimizations. So this is going to be talking about a lot more in terms of end-to-end system performance. You just need a separate session for DAX. We're not be covering that here. And we highly recommend you download this deck for reference because this is going to be like useful tips for you to go through for every single project you're going to be working on in Power BI. Okay. And why do we want to do performance management, right? And the primary goal for performance management is to make sure the end users who are using these reports and dashboards are satisfied, right? They want to make sure that when they're actually using the reports and dashboards, these are extremely fast and make sure that they are able to get the data what they want to analyze, right? And the key benefits of this essentially is you want to make sure you utilize the resources which you're paid for efficiently and also lower the cost as needed, right? And also you want to avoid scenarios where there are certain CEO dashboards or important dashboards and they are become extremely slow, and then you need to go and fix this in a reactive manner. So we want to make sure we're providing all of the information so that you can proactively design the dashboards with performance in mind. Okay. In order to do this, you need to have a deeper understanding of the product and the service behavior. Okay. So a lot of the things which you will be seeing today is a lot of this is from the learnings from the engineering team, the customer advisory team, and the interactions we have had with various enterprise customers. Right. So a lot of them are architecting solutions for their needs. And as and when they come and share information in terms of performance issues, we debug and analyze and provide guidance. So a lot of the things are learnings from the entire team. And we want to make sure that we provide all of these benefits so that you can proactively design your dashboards and reports with performance in mind. And what can affect performance, right? So we have two different areas. One is the shared capacity, and then you have the premium capacity, right? So you can just essentially have like Power BI Pro, and then you have a premium capacity which you can purchase, right? In both of the cases, you can design your reports and dashboards inefficiently, right? The data models can be inefficient, right? And how you use in terms of direct query or import or row level security, all of these, each and every design choice which you have can impact performance. So you need to be aware of each of these and how do they affect performance. Those are key things which we will be talking about in today's session. Okay. Now Power BI Premium. So what is special about it, right? So one of the key things when you purchase Power BI Pro, you are in a shared capacity. right? So a lot of the customers, they wanted to have a separate dedicated capacity so that just for their organization or just for the team. So and one of the things which we did was a Power BI Premium. So it's a premium is a capacity that's dedicated for you so that you have all your dashboards and reports in the premium capacity. So you avoid the noisy neighbor problem so that you're not impacted by others. OK, and you still need to do good design principles in terms of performance to make sure that even in the premium capacity, you are essentially utilizing the resources effectively. OK. And then we also introduced Power BI Premium per user, right? So this is a recent introduction, and this is primarily intended for smaller organizations and need advanced professional features. So that's kind of what this is being targeted for. And what do you get? You get pretty much most of the features of Power BI Premium. There are a few things which you don't get, like multi-geo support, unlimited distribution, bring your own key. Those are like very advanced things. Those are things which you don't have, but you get majority of the features of Power BI Premium to use Power BI Premium per user. Okay. And more recently, Power BI Premium, we've actually have a generation 2. And some of the issues which you might have seen in the past, those infrastructure issues should not be there. We have greatly improved the scale. When there are peaks and spikes of demand, those will be proactively addressed, and the auto scale can be automatically applied, and the reports should be faster, right? Based on our evaluations and metrics, typically we've seen like 16x faster. So in general, you should see these performance overall. OK. So with that introduction, we want to get into architecture and configuration so that you have a good understanding of how the Power BI architecture works. OK. So at a high level, you publish reports, right? So you are developing your reports in Power BI Desktop, and you're publishing the reports directly to the service, right? And you need to choose the right storage mode. You need to make sure that the network latency is as limited as possible. And you want to utilize all your resources efficiently, right, to get the best performance here. Right? That's what we'll be talking about. How do you have a good understanding of the architecture, and how do you go about doing this in this session? Okay. So what you see here is a simple architecture of Power BI here. And in this, on the left-hand side, you see in terms of a user who's actually creating a Power BI report in Power BI Desktop. And obviously, they can pull in data sources from anywhere in the cloud or on-prem. And then they create a workspace, and then they publish it to Power BI service, right? So in this, the right-hand side, you see the Power BI service. You have your dashboards and reports which are there, and your end users are consuming these reports. Okay. So where is the time spent? So obviously data sources is going to be a very, very critical key, right? So how are you connected to the data sources, right? So you could have been connected to the cloud data source, or you could be connected to the on-prem data source. And there are two different types of modes in terms of there is a scheduled refresh, which will affect if you are importing the data, right, from a cloud or an on-prem data source, refreshing and data refresh can affect the performance. And then there is also cases where you have live connection or direct query, right? So you set up your reports to do live connection or direct query. And in those cases, whenever your end users are interacting with the reports, it's going to go and get the data from the data sources, and that can affect performance. So you need to be aware of where is the time being spent, right? So it can be in the part of the data sources. The second one is the time could be being spent on the on-prem gateway. So if you have on-prem data sources and you're connecting to them, you definitely need an on-premise gateway, and there could be time being spent there. And then the third area is more in terms of network latency, right? So as you are working on your desktop report or using the Power BI service, there could be network latency from Power BI service to the cloud data source or the on-prem data source or to the end user. Their network latency can be affected in multiple different locations. So you need to be aware of where the network latencies can be potentially be affected. Okay. So these are three key things which I want you to make sure that you keep in mind. If there is a performance issue, there are these three things in terms of data sources, gateways, and network latency. These can affect performance as part of it. You need to be able to understand and then optimize all of these to the best for your organization. Okay, the first one is the storage mode, right? So you need to make a decision whether it's an import mode or a direct query, right? We always recommend import mode is the first choice, right? Depending on the data model, you want to make sure that you import the data. And when you import the data into the Power BI desktop and then you publish that report, all of this data is directly in the Power BI service that's going to be giving you the best performance, right? When the import mode is not appropriate, you may need extremely large data volumes, right? When I say extremely large data volumes, this is like hundreds of terabytes in terms of like terabytes of data. And we still do, as you import the data, we will compress the data, but like I've still seen a lot of customers want large data volumes, or they want near real-time access directly to them, right? So these are some of the common things where you may not want to have import mode. The third area here is you might have an existing investment, right? It could be a multidimensional model in analysis services or tabular, or you have SAP HANA. So these are existing investments which you have. You want to be able to directly connect to the existing cases, right? So that's an area where you may not want to do it. The fourth area we have seen is there are regulatory requirements that the data cannot go outside of a specific country. So you might have your investment directly like analysis services with the or SQL Azure data warehouse within your country. And you can still through Power BI, you can query this data directly, right? Because the data is not moving away. So you're directly querying the data. So this is what we have seen in terms of the import or direct query mode. Okay. So storage mode considerations. So source data, when you actually import this into Power BI, we have typically seen anywhere from 5x to 30x compression. Typical rule of thumb, we recommend to customers anywhere 5 to 10x. You might want to see that like the data will be compressed. Then the second one is if you have larger data sets, can you consider premium, or do you want to consider Azure analysis services, right? Those are potential options for you. And we also have a new additional features in terms of blended architectures, like where composite models or aggregations. These might be considerations for you when you have large volumes of data. One thing you may need to be aware of, there might be some limits with DAX when you use the direct query mode. So these are typical things in terms of what you need to be doing as evaluation as you are looking at the data and which storage mode to evaluate. The second area is reducing the network latency. Okay, so you have various components as part of your architecture in terms of your data sources. You have the gateway, and you have to have your Power BI tenant where it is located. So these are essentially potential network latency bottlenecks you might be there available, which might be there. Okay. So in order to reduce the network latency, you want to locate as much as possible, co-locate all the services, right? In the production support, co-locate all the services as close as possible. So this is in terms of the data sources and gateways could be co-located together, and you can locate it as close as possible to your Power BI data center. Okay. And cloud replica of on-prem data sources might be another consideration. Instead of on-prem, if you can do a cloud replica, that will help you. And in terms of leverage region-specific Azure analysis services, right? Depending on where your Power BI data center is, you can actually try to put your Azure analysis services closer to that, or the VMs closer to that. And then we highly recommend also Azure Express Route. I've personally seen huge benefit for one of the customers I worked in the very early stages. Azure Express Route reduced the network latency by like close to 50%. Okay. And then the third area is you want to make sure that your gateways, right? This is what the third area which we looked at. You want to make sure you are utilizing the gateways effectively. So the scenario here is the gateways will be able to provide support for refresh and direct query, and this could be in terms of the performance could be bad, right? This typically what we have seen is people are using a single gateway for both direct query and scheduled refresh, and this is might be okay if you have very small data set. When you have a lot of data set, that can have an impact, right? And that could be having contentions in terms of the resources, which can be negatively affecting things, right? So in order to do this, again, follow the best guidelines in terms of minimum 8 cores and 16 GB. And primary recommendation is separate out your gateways. If you have direct query sources, put them into one gateway. If you have scheduled refreshes going on, put them in a separate gateway. This will explicitly help you in terms of debugging the performance where the issues are. And then set up monitoring. There is a, if you follow the link from the report from that PowerPoint deck, you can look at how to monitor the gateways. And then based on the monitoring, you can do a scale up or a scale out. Depending on the perf counters, you can set up the gateways appropriately. And then there is a perf tuning guide, which was published. We highly recommend that you utilize the perf tuning guide. And then it also includes a Power BI template to analyze all of the data coming out of the gateway. These will be very, very useful for your monitoring. Okay. Now, another tip which we highly recommend is in terms of use premium query caching, right? So whenever you have reports, you want to make sure that the performance of the reports are very effective and fast. So if you have a frequently used report on premium in frequent refresh, like 1 to 2 times per day, you can actually set this up. And the report slows down due to high usage and query complexity. This is a typical scenario, right? So in order to do this, avoid this particular one, because people are coming and querying this like only 1 to 2 times per day, and then they see very poor performance, right? If you turn on this query caching, by default it's off. If you turn on this query caching, the results will be cached in the Power BI service, and that will enable in terms of speed up the performance for the end users who are seeing this. Okay. With that, I'm going to hand over to Phil for the next section on data modeling.
Thank you, Siva. The next section, we're going to talk about data modeling. And specifically, we're going to be looking at the analysis services component that is the underlying platform for reports and dashboards and pretty much everything that runs on Power BI. So it's very important that we get the data model running as efficiently and as optimally as we can. So at a high level, an inefficient data model can really ruin your end user report experience. You don't want to have end users loading your report and it taking 20, 30 seconds or even longer, especially even on very small data volumes. So what are some of our goals with data modeling? Well, first, we should be trying to make the data model as small as possible. And, as noted here, there might be exceptions to this rule, but our objective is to try and make the data model small. Now, this can be quite counterintuitive because analysis services applies data compression when it's loading data into the model or storing data into the model. And in other domains, data compression means you need to decompress the data before you can use it. But with analysis services, queries actually can derive their result over the compressed data. So the more data compression that we can get, the better it's going to be, because first of all, a smaller data model is going to make better use of the capacities, but also query speeds for the end user will be a much nicer user experience for them. So the schema should support the overall analysis and exploration path. So make sure that your data model is going to solve the questions that it's intended to solve, and that you do take care and time and think about the relationships that you build into your data model. So what are we aiming for when we're designing a data model? We're aiming for a star schema. So this is a pretty well-known topic, but if you haven't done any reading on this, I recommend you look into dimensional modeling. So the idea is that we're going to separate data into either facts or dimensions. Now, facts are actions, activities, transactions, events that you want to count and sum and measure, while dimensions are typically the data that you would like to group and filter by, such as date. I perhaps want to count the number of activities by month, or sum the number of quantity or sold, over for a given product for a year, etc. So this usually requires denormalizing. Not all your data sources will be in a denormalized format, so some ETL work may need to be applied to your data. And denormalizing is the process of creating that redundancy, creating those dimension tables that support the star schema. But don't go crazy. Don't try and make lots and lots of dimension tables that call other dimension tables, that join to other dimension tables for the sake of it. Do keep your data models fairly simple. Perhaps one or two relationship join at the most. So here's a picture of what a classic star schema might look like. So we have a sales table in the center here, and that is connected. This is our fact table, and the fact table has a number of ID columns. These are integer ID columns that link to the ID column that happens to be in the related dimension table. But what we also have in the fact table is a couple of numeric columns that we can perform aggregations over, such as sum, which would be the most common, but we can do max, min, average, all the types of calculations that typically pop up in an analytics and reporting workload. So first of all, select your business process. So in this case, we're choosing sales. We're going to declare the grain. Now, what does this mean by grain? Now, a grain in a sales table could be perhaps the overall basket that occurred during the sales transaction. So the total amount that was spent, the number of products that were purchased in that basket, or the grain could be at the individual transaction level. But you declare and you decide what that grain is going to be. Step 3, identify the dimensions. So think about, how will I like to filter and group this? Do I just want to look at by date, the last 3 months or the last 3 weeks, for example? Let's just group this by product category or supplier, etc. And that will help you define and create your dimension tables. And then lastly, identify the facts that you want to measure, such as the ability to perform a sum or a max over a quantity or item amount or line total amount, tax, etc. So once you perform these 4 steps, you should be in a pretty good state and deciding what to bring into your model. Because importantly, what you don't want to bring into your model is data that is not required for that. So some people make the mistake of perhaps connecting to a data source, just bringing in every single column, every single row, and that's just extra space into your model. And often it's not needed. Because why? Well, first of all, it perhaps makes your model a lot larger than it otherwise needs to be. It's going to mean extra time to perform the initial load of all that data into memory, and each time you want to perform refreshes over that over the data set, it's going to take longer, as well as usability. If you've got a lot of unnecessary tables and column names, when you've got someone who wants to connect to your data model and create a report, you don't want to overwhelm them with lots and lots of columns and header table names, etc. It'll be very difficult for them to find the objects that they really need to build their report in the self-service scenario. Try to avoid high precision and high cardinality columns. So this is talking to the compression element. So again, a lot of data sources, traditional relational databases, it's very common for you to get an ID column in a table that is unique. Now, this is helpful for a OLTP scenario that performs a lot of single line insert, updates and deletes, but these columns are not that useful in a BI solution. So what you should do is try and identify and remove these columns where possible, and even splitting the high precision columns like date and time into their own column type. So you have a column dedicated to the date element of when a transaction took place, but you have a separate column, or remove the time element completely, for example. And you can also apply this trick over to very large numbers to help improve analysis of services ability to compress the data as it's reading in during the data refresh process. So this can net result in faster query speed, smaller data model size, and faster time to load the data into the model. Where possible, it might be a good idea to use integers instead of strings The reason why is because immediately when we have a column that uses a text value, we need to create a separate dictionary to keep track of every single unique type of text, because we effectively created integer value for you. But if you're doing that upstream in your ETL process, you're going to get a, it's going to be a lot faster to refresh the data in, and again, probably have a positive effect on query speed. Once you have loaded your data into your model, I strongly recommend that you review the model metrics. So there are a couple of ways that you can do this. You need to use what we call the Vertipack Analyzer tool to study the model metrics. Now, this can come in Excel format, but it's also now built into the DAX Studio product as an advanced tool. So once you've loaded all your data into the model, have a look at this in DAX Studio. And what this can do is very quickly flesh out perhaps which columns in your model are using up the most data. You know, if you have a data model that might be 300 or 400 megabytes in size, with 100 columns across all the tables, you may find that only 2 or 3 columns in that model are using 80% or more of the space. And once you've identified these columns, then you can check to see, well, do I really need these columns? And this is a great way for you to potentially optimize the model very quickly and easily without reducing the ability for you to do reporting and analytics with that model. Definitely be careful with bidirectional relationships. So when you are joining tables together, it is possible for you to enable filtering to go in both directions. So the traditional direction is perhaps a filter that's applied onto a dimensional table in a star schema automatically applies that filter down to the fact table. Now, what you perhaps don't want to do is have filters that are enabled on the fact table go back up and filter the dimension table. There are a small number of scenarios where this can be useful, but it's often these can be solved in other ways. So if you are using bidirectional filters, I recommend you just double check, re-review, and see whether you can produce the same output using a different technique. And as suggested here at the end, only use BiDi where the business scenario requires it. Do not turn it on by default and leave it on by default. Aside from performance issues, you can actually get unexpected results as well in each cases. We've got a pretty good data modeling technique called composite models. It's an option instead of pure DQ. Now, there are definitely reasons why you would want to use DQ, as Siva mentioned, but what we can do is mix and match the storage mode used by tables in our data model. So rather than have every table 100% DQ or every table 100% import, what we can do is leave our very large tables in direct query mode, but we can have our dimension tables in import mode or dual mode. Now, dual mode means they can operate in both. But also, what we can do is create summary tables and import these much smaller tables, such as just sum of product, sum aggregated by year and subcategory. Now, the end result table here could only be several hundred rows or several thousand rows, where the underlying fact table could be millions or even billions of rows. And now, ideally, when we set up aggregations and ag awareness within Power BI, when the end user loads the report, hopefully most of the visuals that start can actually get their result by querying one of the aggregate tables. Now, this is something that can happen automatically when you use the ag awareness feature. But the key thing here is that these are import tables. These are small in memory, and the end user queries will only escape to direct query once the end user has started to filter or drill down to a specific range that can no longer be supported by one of the aggregate tables. Now, we're also introducing a new feature this year called automatic aggregations, where we can take your end user activity, study that, and recommend and suggest the type of aggregation table that might mean a large number of your typical your user queries can be satisfied by the aggregation tables that it suggests. Now, these would be in import mode, with the your very large tables still remaining in direct query mode. So that was data modeling. So now what we're going to do is hand over to Siva to give us some suggestions, some tips on dashboard optimization.
Thank you, Phil. As Phil pointed out, one of the important things as part of this, we want to make sure everyone learns is one of the important, at least I consider the data modeling optimizations are very, very critical in terms of both for reports and dashboard optimizations. So you need to make sure your data models are very well optimized, right? That's number one step. Okay. So with that, we have two things. After you've done the data model, you have reports and dashboards. We're going to do first dashboard optimizations and then get into reports. So as we get into dashboard optimizations, so this is where you see once the reports are uploaded, you create dashboards from the reports. So that's the section we're going to be first going to be talking about dashboard optimizations. Okay. At high levels, when we design the Power BI dashboards, the way we thought about it is the dashboards should be giving you a very, very fast summary view with the ability for users to drill down into reports for further analysis. And so I want to give an analogy, right? So when you have patients in a particular hospital, typically you get a summary view of the patient's health using their blood pressure, how their pulse rate and heart rate, all of them, right? So think of the dashboards as very similar to the summary view. And then if there is something that is not correct, then you do further analysis on the patient to understand better information. So think of the dashboards as giving you a very simple high-level overview, summary view of this. Okay. And it depends on how you architect the dashboards, right? So you want to make sure that the dashboards are architected efficiently. And one of the key principles as part of this, we want to make sure that you're doing a launchpad design principle, which we'll be talking about. Okay, because some of the configurations, what you do for the dashboards can reduce speed and that can impact the performance. Okay, so now getting into employing a launchpad design, right? So dashboard, the scenario what we've seen is dashboard contains many detailed visuals, right? Now, if you have a lot of detailed visuals, this is typically undesired, right? So you want to make sure that the dashboards gives you a very quick summary overview. Okay, when you have a lot of data in the dashboard, very detailed data, then the end users who are seeing this are probably going to be like overloaded with a lot of data, right? So you want to make sure that you are providing the right level of data which the end users need in the dashboard. Okay. The proposed solution here is only provide the summary and outliers in the dashboard tiles. So one of the common patterns we have seen is people create a single visual and they make it as a report tile, right? They start pinning a report that has a single visual and they will form a dashboard with a lot of these, right? Why is this undesired? When you have a single visual report tile, these are not automatically, the data is not retrieved and cached, right? And it's executed on demand. The dashboard load time will become slower, right? So the recommendation we have is typically pin a visual into the dashboard. Do not pin an entire report, right, fully. So pin visuals instead of the entire report page. If you have a lot more information that you need to pack in within a particular visual, create a custom visual. Even within our organization, there are multiple teams where I had recommended prepare custom visual depending on the scenarios. And we highly recommend that you use only one live report page in a dashboard, right? This is something which we have seen as a usefulness for several of the customers, but generally we recommend just do only one. Okay. The next area is avoid very busy live report tiles, right? So this is essentially people start pinning a report tile. As per the previous step, I've seen customers pinning a single live report tile, but they pack in a lot of visuals. Again, why is this undesired? When you have tons of visuals, when you have report tiles, live report tiles, the data is not cached in the Power BI service. So when a user comes to the dashboard, Power BI has to go and query the latest data, because what this is a live report tile. So we always try to go and fetch the data, latest data. And when you have a lot of visuals, I've seen like some customers have like 50, 60 visuals, right? So then it has to go and fetch the data for each of these visuals. And that creates the dashboard to be really, really slow, right? So propose solution, print individual visuals again from the report page, and make sure what is most critical, and only the important critical ones you should pin here into the dashboard. The next step is manage the direct query dashboard cache refresh, right? So you have direct query which you have set up, right? Typically you will have this set up with row level security, which we call as RLS. And when you have a lot of this with direct query, when you have row level security, what happens is individual users, depending on the row level security you've set up, individual users will see different data. So then Power BI will need to cache all of these visuals. It has to send queries whenever there is a data which is updated. Power BI is going to go and get the data for all of these users, right? And that becomes undesired because it can overload your system. We try to proactively manage it, but it can overload the system as well. So one of the settings which we've added is refresh frequency. How frequently do you want to refresh it? Is it every hour? Is it like every 6 hours or once a day, right? So reduce the cache frequency, refresh frequency, especially with the external data warehouses, so that you get the best performance and you optimize the performance in terms of not overloading your backend systems. Okay. So these are some of the tips we have seen in the dashboard optimizations. With that, I'm going to hand it off to Phil for report optimization.
Thank you, Siva. So the next section we're going to focus on is report optimization. So reports, when the end user loads your Power BI report that you've published to the service, what happens? The report can go to analysis services and get the data from here, perhaps if it's been imported, or it can reach out to the direct query sources out in on-premise and in the cloud, etc. So this is where the time is spent. So at a high level, every report page has a number of visuals, one or more visuals, and each visual will generate queries against the source data. Now, every single visual will generate at least one DAX query, and each DAX query can be one or more storage engine queries. So a single matrix query, for example, might be broken down to potentially 20, 30, 50 or more queries out to the import or direct query source. Queries get sent in parallel batches, and only a certain number at a time can be run. So if you do have lots and lots of visuals on your page, it can be a bottleneck and a problem, causing your page to take a long time to run. So goals to produce an efficient and optimized report page is to try and reduce the number and complexities of queries on that page. So a good rule of thumb is probably 6, maybe no more than 10, but certainly if you've got 30, 40 or 50 visuals on your page, then it is going to take a long time to run, no matter what the data source. So, and that's going to reduce the amount of data that's been moved back and forward, and as I said, how many queries there are. So what you're trying to do is identify on a slow running page which visuals have got the slowest DAX, and I've got a tip on how to do that shortly. So for our tips, first of all, try and reduce the number of visuals on the page. So as mentioned, we consider a high number of visuals to be 20, although it depends on the visual as well. If it's a simple KPI visual that just shows one number, that's going to be quite different to a matrix visual that has expanded or collapsed hierarchies, where the engine has to do an awful lot of work to go and figure out what those numbers should be in every single cell. Depending on your data source, you could simply just overwhelm it. So this is a reason why perhaps you should reduce the number of visuals that happen to be on the page. Here we suggest, perhaps 8 visuals on a report page would be quite good. Let's move our slices across to the filter panel, for example, and automatically pre-select some filter and slicer selections. So if you set a filter setting and save it, that's going to be the default setting that an end user will have. So rather than give them all data for all time, perhaps pre-sort it for certain geographies or time ranges, etc. And you can use drill through and also combining multiple visuals like individual cards into a multi-card is a good way of reducing the number of DAX queries that are required to produce the report. Definitely use the Power BI Desktop Performance Analyzer as a tool. So when you do know that you've got a slow loading report page, you can turn this traced tool on, and it can help you identify of all of the visuals on the page, which ones are taking the longest amount of time. And as shown here in the little snippet, you can, once the page is loaded, you can sort the results by the DAX query in descending order to perhaps identify which visuals have taken the longest time to run. And once you've got that DAX query, you can take it over to a different tool like DAX Studio to perhaps rewrite your calculation, do some internet searching, see if there are alternatives about how you can produce the same result, but using a different technique. But I would absolutely recommend the desktop analyzer, performance analyzer, to figure out where the low-hanging fruit is. What would be your biggest bang for your buck? You should review visual interaction. So in Power BI Desktop again, and when you're in authoring mode, every visual has the ability for you to turn on or off how it cross filters with other visuals on the page. So if there are some visuals that you don't want to cross filter, definitely turn this off. It can speed your report load up, especially when it's absolutely unnecessary. And there's the example here is when I have a visual highlighted over here with the edit interaction feature turned on from the format tools, I can specify that I don't want this slicer to interact with this other slicer here. Sometimes you do, but if you definitely don't, turn it off, and that can help speed up the report page. Use filters to limit the visuals. So rather than show a matrix or a table particularly with thousands and thousands of rows, perhaps make good use of filter panels and filtering to just reduce the number of rows required when the end user first arrives at a page, when all of the other visuals are being loaded at the same time as the matrix, but then they can perhaps expand the matrix and update a filter to get more data as and when they need. And you can use the top end filter to help with this, as well as other drill through techniques as well. Try and avoid slices with very large number of values, which can have an impact on how much memory is required to run the report, especially when there are multiple slices on the page. So just take care and think about what slices you might want to use in your report, and use the filter panel instead of the slicer. There's less effort to populate and support the values and selector to filters in the collapsible filter panel using that new filter experience. As I mentioned, you can use slicer to selection defaults. So perhaps instead of just showing the end user when they initially load the page all data for all of your options, go in and preset some of these filters to what they might be, what might make sense to a user, be it a time range or a geography or a set of products, for example. So set the filters, save it, and actually use bookmarks as well as another way to allow people to jump between different default settings of slicers. So this can, again, it's going to make the effort to generate the queries much smaller and make better use of the capacity, and your report page should load faster. Do be careful when you're considering synced slicers. They can be very helpful. Now, a sync slicer is a slicer that you can set on one page of your report, that when you make a change to that, it automatically updates a slicer setting on a different page in the report. So, but it can have impact on how much memory is required and how many queries need to get generated. So again, make good use of filters instead of slicers, and perhaps restructure to provide drill through detail, and consider embedding with global filters applied to the external UI when you're using Power BI reports in an embedded scenario. So with that, I'm going to hand it back over to Siva, who can give us some tips on data flows.
Thank you, Phil, for walking us through report optimization. So in this section, I'll be covering in terms of tips for data flows. So data flows at a high level essentially is Power Query, which you're familiar with in the Power BI desktop. It's on the cloud version of it, and it's with the results being stored in Azure Data Lake Storage Gen 2. Okay. And it shares the components with Power Query, and the benefits from the same optimization. So all the optimizations you're doing in terms of Power Query, you should be continuing to do the same things. Okay. And the key goals here, pushing the work completely to the data source rather than you doing a lot of the compute, pushing the work to the data source, and avoiding the memory or CPU intensive operation so that you're spreading them out, right? So that you can spreading it much more diversely. Okay. One of the first step is separate the ingestion and the transformation, right? This is very, very critical. So that like what all the things that are ingesting the data, you need to separate this from the transformation, right? So here the core scenario here, there could be complex data flows you're writing on large volumes of data, right? And when you do this, and it can overwhelm your source or gateway, depending on where the data is, it can overwhelm, and it could be slow as well, right? So as part of the proposed solution, create a separate data flows for ingestion, right? Separate out ingestion data flow from transformation, perform the transforms in a separate computed entity, create a computed entity or do all the transformations. And reading from a data flow is faster than reading from the source, right? So essentially, if you're doing this as a computed entity, all the ingestion coming from a data flow is going to be much faster, right? Additional performance related capabilities for computing entities will be coming soon. So as and when we improve the performance, like you can essentially be able to get benefits from this. Okay. Another tip which we've seen in quite a bit of customers is complex data flows on premium. We've seen this failing or taking an extremely long time, right? So the proposed solution for this, we have some properties in terms of the container size. So on the right hand side, you see the diagram in terms of the container size. You can increase this container size, max memory of the workload to allow data flows to use the total memory for better parallelism, right? So this will essentially utilize the full maximum power in terms of the utilization. It can affect some workloads, so I just want to make sure you're aware of it. And if you run into this is a proposed solution which you have. And then we have Chris Webb, who's also part of the same team from Phil, where Phil is in Power BI Customer Advisory Team. We will encourage you to look at Chris's blog post on the container sizes. Okay. So with that, I am going to be handing back to Phil for covering data loading and refresh.
So thank you, Siva. So the next section I'm going to be talking about is all around data loading and refresh. So where does the time get spent in the data loading and refresh? Well, again, it's all in the analysis services element, which may be and it sits between analysis services and again via the on-premise gateway to the on-premise data source or directly to the cloud data source. So at a high level, what is data loading and refresh? So data loading can include connecting and retrieving data from a data source, but additionally, any transformations or any work that we do to change the data as it's being loaded into the database. Now, if you're lucky, a lot of that work is being done already in your data source, so there's very little for you to do. And this is probably quite an optimal scenario. So perhaps you're connecting to a data warehouse where you already have a fairly clean set of fact and dimension tables, but not all data sources are like this. You know, you might have CSV data sources or external data sources that you don't have an awful lot of control over. And when you connect and start retrieving that data, you need to do some work to convert it to the star schema optimally for Power BI. Now, Power Query allows you to perform a lot of point and click functions. Now, some of these can really slow down the time it takes to refresh data in. So what the goals are when you're doing your data load design is to try and push as much work upstream to the data source as you can get away with. And as I mentioned, sometimes you have this luxury, other times you don't. But if you can, certainly try and push it up where possible. And definitely try and avoid as much memory or CPU intensive operations or spread them out. It's not unusual when we are investigating slow data refresh problems, for us to eventually find out that the gateway machine is very busy simply because of the number of transformations that are being applied to the data as it's passing through, as it's being loaded in. So data loading and refresh, memory size. So what you also need to understand is that the amount of memory required is not exactly the same as the model size on disk. So you could previously look at the size of your PBIX file and say if the PBIX file was 20 megs, then the data model size might be 20 megs. But the PBIX files are now compressed quite significantly. So a 20 meg PBIX file could actually mean a much larger data set size in memory. So please be careful of that. And if you're performing a full refresh of your data model, you need to allow twice as much memory on your capacity than the data model size has. So for example, if you have a 100 meg data model and you decide to perform a full refresh of that, then you need to make sure you have at least 200 meg available to perform that full refresh. Because what we do is we keep the original data set available so that your users, when they are issuing queries and their reports are running, they will use the original data set, and we create a brand new object in memory, and then we hydrate and we populate that. And when it fully refreshes, which might be another 100 meg model, you're currently at that point using up to 200 megabytes. And then only when the full new object has completed filling with data, refreshing, do we remove the original object. Now this is instantaneous. Your end users get no errors, they get no break in transmission, but just make sure that you allow that much memory when you're performing your refresh. Make sure you use query folding. Now, so what is query folding? Now, query folding is the ability for the engine to take your M transformations and generate in the dialect of your data source a simple calculation, a query expression that it can push up to the data source. So if you're doing filtering, grouping, some basic expressions, for example, ideally what we're doing is we're pushing out some T-SQL to a SQL database, or other types of dialects that make sense, and they're simple. They're one statement that the data source can compute and then return the bare number of rows required that you've asked for, rather than go and get an awful lot more data than you actually need and perform those operations in memory in Power Query. So when you have native queries, when your transformations can still generate a native query, that's a very good thing, because that will mean less data movement back and forward. So what kind of queries can be folded? Well, traditional sources like SQL and Oracle, where we've got that ability to generate the query expression in the native dialect of the data source. OData sources, Active Directory, this is not an exhaustive list, and this is evolving over time. So it's a very complex area, and it's something we're always improving. But keep your eye on, are you able to generate native query folding against your data source? You'll get a faster query experience. Use less memory and CPU if you can do that. So you definitely want to try and avoid scanning whole large tables. So this is any grouping and aggregation performed in M that would require a lot more data to be loaded into the M engine to produce the result. Where possible, what we're trying to do is reduce the amount of data that needs to be collected from the data source and how much work needs to be performed during M. And some solutions here say, perhaps what we can do is, for measures, use DAX rather than M to perform the sums and the groups and the counts, etc. And also what you can do is you can customize the source query using the advanced editor to push the operation to the data source. Now, we do have a small number of data sources that allow you to paste in native queries now. This has been released this year. So if you do know how to write optimal queries for certain data sources, then you can now do that, which is worth doing. But the queries need to be foldable and could be used as a derived table or a subquery So there are some limitations around what would work as a native query, for example. Try not to load intermediate table queries to the model. So if you are using intermediate tables, say you create a duplicate of a table, you perform some grouping, and then you join it back during a complex M scenario, but that's all it's used for, then don't load it into the underlying Power BI data set. So you can untick the enable load feature here to reduce, to treat it as something that we throw away, that we use the intermediate table to perform the action that we're trying to achieve, and then when we know we no longer need it, don't load it into the final data set. And lastly, this is quite a biggie. Make sure you turn off the autodatetime feature if you're definitely not going to use it. So if you do have a calendar or date table in your star schema model, then make sure you go into the settings and turn this off. Otherwise, what you'll get is a little table with as many rows as there are to cover the date range for any dates in your model. And this can turn a very small, simple PBIX file into a very large table if you're not careful. So if you're following Kimball, you're doing a star schema and you have a date or calendar table, please go on and turn this off. If you're doing some ad hoc one-off analysis, sure, leave it on. But if you have a lot of date time columns in your data set, then this can potentially make your data set a lot bigger than it needs to be. So with that, I'm going to hand it back over to Siva to tell us about performance management framework.
Thank you, Phil. So with that, we come to the last section in terms of performance management framework. Okay. So the common question is where to focus, right? So obviously, as we've seen in the talk, there are multiple layers in Power BI. You need to be considering performance in every single layer, right? Review the end-to-end architecture. Make sure what is the right data source you're using, right? Is it in different regions or the same region, right? So make sure that you go through that systematically, okay? And one of the best things which you've done is when you're designing the reports and dashboards for the end users. So start working with them. Start from the visual layer first. Do the visual layer and essentially start from the visual layer, and that makes it easier in terms of making the changes in the visual layer, and then you can now downstream you can look at other things. Okay. So measuring performance and then making sure there are no performance regressions. This is one of the key things in terms of the performance management framework. We highly recommend you make an initial baseline, right? So when you take, we want to make sure you systematically are approaching this as more of engineering in terms of preparing baseline. So you are actually creating the reports in Power BI desktop and then publishing this to the service. Build the baselines, both the Power BI desktop and in the service, right? And as and when you're making changes into your report or data model, find out are these affecting performance, right? So this is a good way for you to understand in terms of setting up the baseline and any change you've made as this impacted performance. Okay. Also, when you're setting up targets to the customers, end users, make sure you set up reasonable targets, right? Depending on the number of visuals and what complexity of the model, you want to make sure that at least the percentile, 75th percentile, is somewhere. We'll give an example of 12 seconds. It could be 6 seconds in your case, right? 6 seconds or 5 seconds. So make sure that you work with them and make sure that you set the right expectations so that once you set the expectations, people will be used to that expectation. And then build performance management into your solution lifecycle, right? As you're building new reports, enhancing it, and then publishing it, you want to make sure that you are systematically, you build a baseline. Now you want to be able to start testing this at scale, right? Use the VST as web-based testing or scaling it through Azure DevOps so that you can actually test for performance completely, right? Create the baseline for each and every model and report which you're doing so that you have isolated each and every model and you know exactly where the performance stands for every change you've made. Okay. And knowledge sharing and performance awareness. It's very, very critical. There are multiple users you might be satisfying. First is self-service users. You might be preparing a data model and asking them to create their own reports, right? So as part of it, you can give right guidance to them, right? You give them a Power BI template file, right? PBIT file. that will be able to, with that, you can actually create a template with X number of visuals. That's what the common guidelines are within your organization. Make sure that you are educating them with the right set of templates prepared so that self-service users can actually create their own reports and make sure that they get value out of the data model. Now, when you get into enterprise BI, you want to make sure there is a formal performance review before moving into production, right? Very similar to running a website or pushing production code. You will measure for performance. Make sure that you do the same thing, right? And in this talk, we have covered a lot of in terms of architecture and data modeling. Obviously, there is DAX at another level of performance optimization which you can do. Make sure that you do have a formal review of DAX expressions and optimizations as well. Okay, and approach the performance tuning collaboratively, because you as a person, as a data analyst building data models, might be one person. There might be administrators who for each and every data source. So you need to be able to work, collaborate with them to make sure you understand their needs, the bottlenecks that they have, and make sure that you're collaboratively solving the performance for all your end users. Okay, set up a process when there's a performance issue, who's going to be investigating it first, then passing on to the next person where the performance might be impacted. Right, there could be things where you might set up data query and another change in the backend system might actually affect data query, right? So set up the right level of layers and process so that you have the right process expectations set with all of your dependent parties. Okay. So with that, this comes to the end of the presentation. We want to cover some of the key takeaways from here. Performance tuning can be complex and can take time, right? So that's the reality, right? Power BI provides you with a lot of flexibility in terms of how you model this. You want to make sure that you take this approach and tune the performance in a systematic, data-driven manner, right? Prepare the reports, set up the baselines, look at the performance, set up in terms of automated testing as well. There are always there going to be trade-offs, right? Depending on the design choices, there are trade-offs which you need to make. And make sure you educate the users with the right set of performance expectations in terms of what they should expect from the system. Okay, and obviously you can do fine tuning of every single detail, but at some point in time there may not be return on investment. Some of the optimizations might be very difficult, so you want to make sure that you tackle the top important ones. Okay. There are a lot of features which we've been adding into Power BI, like the desktop performance analyzers, composite models, aggregations. We'll continue to keep adding as well. So continue to keep watching the blogs so that you can look at the latest features that are released every single month. In addition to that, we also have a set of resources we have provided in this presentation. I'm not going to go through them, but there are 4 slides with all the resources that you can leverage for performance tuning and guidance. So we highly encourage you download the presentation and look at the resources. With that, I would like to thank you all for listening in for the session, and thank you for coming in for this session. We look forward to you learning from this and improving the performance. And thanks to Phil also joining and partnering with me for this presentation. We will be available for Q&A, so please come and join us. If there are any questions, we'll be happy to answer the questions for you.